Hey everybody, Simeon Franklin, your Python instructor from Maracana here. Hey, since we didn't have a lesson this week, I thought I'd send you a video and review some of the stuff we talked about at the end of last week. The topic I want to talk to you about is higher order functions, and as always, feel free to contact me during the week between lessons. You can catch me, simeon@maracana.com, my email address, or direct message me on Twitter @SimeonFranklin. You can leave comments or hit the contact form on my blog. I look forward to hearing from you. Okay, so what are higher order functions? Higher order functions are just functions that take a function as an argument or return a function. So you can call a function and pass it a function, or you can call a function and get a function back. And syntactically speaking, just as a matter of syntax to do this is really easy in Python. Functions are first-class values in Python. That just means they're an object like any other object. If I ask you to pass a variable x that contained the number 5 to a function, well, you'd say its name inside parentheses. And that's what we do with Python. If we want to pass a function, we just, we say its name. So f here in my code is a parameter, and f here in my code I'm treating as a function. You just append the call operator, parentheses, to call a function. I'm defining a perfectly normal function, right? Hello world looks, the hello function here prints out hello world, and it looks very normal. And note, in Python, we could just pass the function hello to the function caller, and if all goes well, this should actually print out hello world. So it does. It prints out hello world down here. Now, I said functions are first-class citizens in Python. They're objects, just like every other kind of value. And it's worth noting, in some languages, the function is a special kind of value, and an object is a distinct and different thing from it. In Python, functions are implemented as objects, and that means that functions have attributes. So look what happens when I call dir on a function to see its attributes. It's got all sorts of special double underscore attributes. The double underscores let us know that this is something particular to Python. Python's giving us these, and they mean something special. Lots of interesting attributes here, and some non-underscored versions of them. So functions are objects, and they have attributes, and we can pass them just like any other value. Nothing special syntactically in Python about functions as values, but why would you ever want to do that, right? Why would you want to pass a function to a function or get a function back? So let me introduce you to my friends sorted, map, filter, and reduce. They're functional built-ins. There is no alternative to sorted. If you're going to sort stuff in Python, you're going to have to know how to do it functionally with higher order functions. So sorted. Sorting in Python pretty much just works. You have this built-in function sorted, and it knows how to sort things like numbers or strings. So a little line of code here, sorted of the list 3, 4, 2, and Python knows that it should be 2 and then 3 and then 4, right? Sorting is easy. If you had a little list of words, foo and bar, and you ran that code, well, you get back bar and then foo. Python knows how to sort strings. It does it alphabetically. So numbers, strings, Python knows how to sort them. But what if you want to sort something a little more complicated? What if you wanted to customize sorting? So if you had a list of numbers and you wanted to sort them by absolute value instead of natural value, here's a list of numbers, 1, -1, and 0, and by natural value, it would be, 1, -2, and 0. It would be -2, and then 0, and then 1. That's the natural order of sorting. But if I did it by absolute value, it would be 0, 1, and then -2. The absolute value of -2 is 2. So we need to customize how sorting works in this case. And to help us, the sorted built-in takes a key parameter. The key just needs to be a simple function that takes a single value and then tells Python, what's the value you're going to use in sorting. So it takes as an input a thing to be sorted and returns as output the value you'll use in sorting it. Well, that's kind of interesting. There is already a built-in function, abs. Calling it does not give you a perfect six-pack. Calling it gives you back the absolute value of the number you pass to it. So call abs with -2, and we should get back a 2. Okay, so if I said sorted, and then my list, 1, -2, and 0, and key equal abs, I'm saying don't sort it by the values you get, sort it by the absolute values of the values you get. And you notice I'm not calling the function abs. I'm passing the function abs to the built-in sorted to be called somehow in the sorting algorithm it uses. Whatever sorting algorithm it uses, at some point it's going to call abs on 1, -2, and 0, and use that to do its sorting. And you can see, hey, the output on line 40, 0, 1, and -2. It did sort by the absolute value. That's pretty cool. That's what I wanted. I could customize how Python sorts by passing it a key function. This is higher order functions. So success. If you want to sort a complicated object, you have to write a key function. It's not a function you're going to call. It's a function you're going to pass to sorted, along with the list of stuff to be sorted. And sorted is in charge of looping through the list and calling your function to get the values to sort by. And there's other functions that work this way in Python. See the built-in functions max and min, they work the same way. You pass them a key function, a list of stuff to be picked through, and the key function tells you, here's the value that I want to use to compare two items. But let's look at some other functional equivalents. There's a built-in function called map, and map does something a little bit more complicated. Map takes an input list of values and returns you a list of different values. It's the same list, it's the same order of items, it's the same number of items, the length is the same, but the values from the input list are mapped to the values from the output list via a function that you get to provide. So here's an incredibly crude hand-drawn sketch of essentially what map is doing here. So map has on the left-hand side, sorry, I'm zooming the wrong way here. There we go. Map has on the left-hand side a list of values, A, B, C, and so on. And on the right-hand side, the output is X, Y, Z, and so on. And how do you get from A to X, and from B to Y, and from C to Z? Well, you do it with that F in the middle, the function. The function will take a single item from the list on the left and give you a single item in the list on the right. And we get to write the function. We get to customize map by providing it a function. So map takes a function as a first parameter, and then the second parameter is an iterable containing data. So here I have a call to map, and I'm passing it str, str, as the function, and a list of the numbers 1, 2, 3. So what happens when I run this map? I get an output list of the numbers 1, 2, 3, but instead of it being the numbers 1, 2, 3, it's the numbers converted to the string equivalent. See the quotes around each number? So this is a quick way to go from a list of input numbers to a list of what I'd get if I called str on each individual number. But I didn't write a for loop. I didn't call the str function. Map is looping for me. Map is calling the str function, and I'm customizing what it does by providing it a function. This is higher order functions. And of course, you could write your own function, right? Check out, I have a simple function here, add2. It takes a value, x, whatever x is, and returns x plus 2. So if you map add2 to the list of the numbers 0, 1, 2, through 5, that looks like the range of 6. Sorry, run my little bit of code here. This is the output I'm looking for. Line 42. So ran my map with the add2, and my initial list of the numbers 0 through 5 has turned the list of the numbers 2 through 7. I get an output list where each item in the output list is mapped to the item on the input list via the function I provided, add2. And again, I didn't have to loop. I didn't have to give myself a new list and append items to my new list by calling my function. Map is handling the looping part for me and the calling the function part for me, and it gives me an output list. Same number of items, same order of items, but the values themselves are changed. Okay, let's look at the next one. So after line 42, we've got more friends that work this way, higher order functions like filter. Filter's really similar. Filter takes a function and an iterable, just like map did. And filter produces an output list from an input list, just like map did. But filter does something different. It produces an output list of every item that passes a test. So again, with the really terrible drawings, on the left-hand side I have an input list of A and B and C and so on. And on the right, I have an output list of A and C. There's no B. How did we choose not to include B in the output list? Well, we did so with a function, and we get to provide the function. That function f, the arrow, is kind of how you get from the left list to the right list. And we apply it all with filter. So with filter, we get to write a function that takes one item from the input list, and it should return true or false. If it returns true, that means, yeah, keep this item. It belongs in our output list. If it returns false, that means, nope, don't want this item in my output list. And just as a bonus, if you look at the documentation for the filter function, you can pass it none instead of a function as the first argument, and it'll just filter by Python's concept of truthiness. So here on line 43, I just ran my little line of code. Filter none of the list 0, 1, 2, 3 gives you back the list 1, 2, 3, right? 0 is false-ish in Python, and all the non-zero numbers are truthy. And you could use the same idea. Here I have a list of strings, foo, and an empty string, just quote, quote, and bar. And again, Python's built-in sense of truthiness on line 44, the output, I just get foo and bar. It's a way to filter out all the non-truthy strings. That would be the empty strings. You can do the same with lists, empty dictionaries, all the container types in Python. The sense of truthiness is built on length, basically. If you've got something in it, it's true. If you don't have something in it, it's false-ish. But let's customize how filter behaves. What if we wanted all the numbers that are greater than 10 in an input list? Well, we have to write a filter function, and I'm doing so. Line 45 here. I'm writing a function greater than 10. It takes a num, and it returns num greater than 10. So that's going to be a true or a false value. The input value is going to be either greater than 10 or not. But I don't call that function, right? I'm going to pass it to filter along with a list, and I'm using the built-in range function in this case. So range 15 should be the numbers 0 through 14. And filter is going to choose to include some of the numbers in the output list based on my filter function. So let's run the code. Oh yeah, 11 is greater than 10, 12 is greater than 10, so on. And again, I didn't write a for loop and an if statement to go through the list and pick just the things I want and put them in a new list. That's what filter did for me, but it did so with my function, my greater than 10 function that I supplied. And if you want to pick from the items on a list by a custom piece of logic, you can do that with filter. Here's another functional built-in, another higher order function, reduce. Reduce is a little bit different. Reduce doesn't take a list and give you back a list. Reduce takes an iterable of input data and it consumes it to come up with a single value. And the function that you write is going to be different. You're going to write a function that takes two items and does something to come up with a single value and returns the single value. And basically the way that reduce typically works, again, I have a hand-drawn diagram. This is the result kind of the execution of calling reduce with the plus sign. And you can't do that, but we'll get to that in a second. So reduce with the plus sign on the list of the numbers 1, 2, 3, 4. And if you think about it, the plus sign is a function that takes two numbers, right? Like you said, 1 plus 2, 1 and 2 are the two arguments to the plus sign, and it returns you 3. So that's basically what we're doing here. Reduce says, okay, I have a list of 1, 2, 3, 4. The first time through, I'm going to add 1 and 2 and get 3 as the return value. And the second time through, I'm going to take that 3 as my left-hand value, and I'm going to get a new value, that'll be 3, from the list, and I'll produce 6 as a return value. And then the third time through, I'm going to take 6, that's my return value, and I'm going to get the next value from the list, that's 4, and I'm going to get 10. And then the next time through, oh, I'm out, there's no more items on the list, I'll just return 10. So a reduce of plus 1, 2, 3, 4 should add up all those numbers one at a time. Now, there isn't really the ability in Python to use plus as a function, right? It's actually, it's punctuation, and Python's parser won't let you do that. But see the operator module, you can import operator, and operator has functional equivalents for all the Python punctuation, all the operators in Python. So reduce plus list wouldn't work, but reduce operator.add would, and operator.add is the same thing as plus, essentially. So let's try that out. Here's operator.mul. That should be the same thing as the multiplication. So we're kind of applying star to a list, and that should be, let's see, 2 times 3 is 6, and then 6 times 5 is 30, so we ought to get 30 out of this list. Yeah, we got 30 there on line 46. Okay. So reduce is a little bit different, but also used as functionally as a higher order function. You pass a function to it to customize what it's going to do to all the items in your list, and you don't have to write a loop. You don't have to write a loop to loop through all your values and process them two at a time, and use an accumulator to hold whatever your running total is, your running accumulation is. Reduce will do all that for you. So higher order functions, they're cool. They can save you a lot of boilerplate flow control code. But we said higher order functions are functions that take functions, and we've seen some examples of that built into Python. But they're also functions that return functions. Is that something that that's useful, that's built into Python, that we'd ever want to use? And if you use a tool called functional closures, this turns out to be a really cool idea. So let's see how functional closures work. So functional closures. First, just remember, it's totally legal in Python to nest your function declarations. So you can put a def inside of a def. So here I have a function called outer, and inside it I'm going to define a function called inner. And then this is really weird. You don't usually see this, right? I'm returning inner. So inner is just the function name. I'm just returning the value, whatever I produce. And that means when I say f equals outer, f is now a function. It's returned from outer, and I ought to be able to call it. And if I call it, I should get hello from inner. Okay, cool. I do. So here's my output down on line 47. So this seems like a kind of a cool, useless party trick, right? You can define functions and return them, but things get interesting. There's this feature called functional closures, where inner functions remember the contents of the scope in which they were defined. So that's a lot to wrap your mind around, I understand, but let's take a look at it and see how it works and how it could be useful. Here's another outer function, and this time I just added a little complication. My outer function takes a parameter, x, and parameters, of course, make local variables inside the scope of the function in which they're defined. So x is going to be a local variable to outer. Inside of outer, I make a function called inner, and inner is going to return x. Now, remember with me Python's lookup rules. X, is that a local variable inside of inner? It's not, but we're referencing its name, so Python says, okay, I'll see if it's a local variable inside the enclosing scope. And mostly we've just seen that being module level scope, right? It goes out to look for a global variable, but in this case we have a function in a function, so it looks for x as a local variable inside of outer, and it finds it. Okay, so that line I've got highlighted, that should be legal, that should work. And then notice we return inner, so we're returning the function, and I'm going to build a couple different functions, f1 and f2, and they should both have different values for x, hello and world. But if I run them, all right, they actually work. f1 prints hello, f2 prints world. You might be thinking, this shouldn't work, because x gets thrown away. When outer is done running, right, x is a local variable to outer, and it should, the stack frame that contains it is just discarded. There is no x once outer is done running. But again, this is implemented because of functional closures. Let me try adding just a line of code here. You remember that functions have attributes. Let's look at one of the attributes that we saw on functions. So this f1 that I made has an attribute called func closure. Let's try running that. And we can see, okay, now the output here says, this is the func closure of f1. There's a cell. I don't know what a cell is. It's got a string object. I'm not sure what that string object is. Oh, that's where it's like storing the reference to what x looked like when it was defined. So f1 remembers that x was hello. f2 remembers that x was world. We have a tool that constructs unique functions, because they've got their own hard-coded value of x, and outer is sort of a function for constructing custom inner functions with a hard-coded variable. Right, you can use closures to build really useful functions. For example, what if we want to sort a list of words by the last character in each string? So you remember we sorted words and we got alphabetical, looked at the first character. We want a function that takes a string and returns the last character, and we'll use that as a key. So here's a function last. It takes a word and it returns word -1. That's the index of the last thing in the string, right? And then I have sorted. This is the built-in, and I've got a list of words: Sheldon, Howard, Leonard, Raj. Key equals last, so I'm telling Python, customize your sorting. Don't do the normal alphabetic thing. Just sort by comparing the last characters. So run that line of code. Okay, D, D, J, N. It looks like that worked. But what if we had a slightly more complicated case? What if we didn't know in advance which index we wanted to sort by? Well, we could use closures to build a key function kind of dynamically. So let's look at this. I have a function called itemGetter, and it takes a parameter called index. itemGetter constructs an inner function, and the inner function takes a parameter called LST, and then it returns the index thing of its list variable. Okay, and itemGetter is going to give you back inner. Inner takes a parameter, and it has kind of a hard-coded parameter because of that functional closure trick. And I could use that to say, hey, look, key equals itemGetter1. When you call itemGetter, what you get back is a function, and the function you get back is a function that'll give you the 1th element in the iterable that you pass it. So this ought to be a way to sort by the 1th character. Let's see, that would be A, E, H, and O. Looks like it works. And we could just change the 1 here to build a different function. Like we could do the -1 thing that we did before and rerun the code. Okay, now we're at D, D, J, and N. Or how about if we did the 0th index? That's the normal thing, right? Then we get H, L, R, and S. That seems right. Maybe we'll try -2. Okay, we got A, O, R, and R. Looks like it's working, and it's working due to the magic of closures, right? itemGetter -2 produces a function that remembers the -2 part and gets handed individual words. We're not calling the function inner that itemGetter produces. We're building a custom inner every time you call itemGetter. So itemGetter is a factory for building and returning a function you can use as a key function. That's pretty cool, but you don't need to build it yourself. See operator.itemGetter if you want to actually use itemGetter in sorting, but it's implemented with functional closures. Okay, that's probably enough for you to get through your homework. Again, if you have questions, I encourage you, hit me up, drop me an email, give me a direct message on Twitter, ask me some comments on my blog, hit the contact form, and we'll talk to you on Monday.